All right. So we revise this paper, Mathematics 1120 1100. It's from sets to binary operations. And that's the coverage for the quiz, which is coming. First question. Given this that the set A, you have got A which is has got the element X which is equal to Z. Now X is from -1 to 12. Okay? And then you have got B, those elements C. Now I want to find A complement. The first thing, let's identify set A. We can list set A. This is not a set of real numbers, so you shouldn't use, like, you can't use you can use an interval, but it will be complex. So you can list these elements because they are integers, friends. Integers can be listed. So this set A starting from -1 to 12. So integers from -1 to 12. But you are not including -1. Martha, let's start listing them. 0. Okay. 0 like that up to 12. This is set A. Now you want a complement. Now the badness is for this set, I haven't been given the universal set. So that's the tricky part with this question. The universal set was not given. Okay. So meaning that the universal set is all the integers going in this direction from 0 and all the integers going in this direction from 12. Now please, these are not real numbers, so don't use intervals. Therefore a complement is going to be, we are going to say X is a member of integers such that X is going to be less than, or this is greater than, X is going to be greater than 12. Now I've said greater than 12, I'm not including 12 itself. Okay, if I wanted to say to be greater than or equal to 13, meaning that we're going to be starting from 13, it is the same thing if I say greater than 12 or greater than or equal to 13, since it's integer and also X is less than 0. Okay, we are not including 0. I could have said less than or equal to -1. It is the same thing since it's an integer. So this is a complement. This is a complement.
Oh, yeah, I get. I was wondering why the emphasis was there.
Yes. Hmm. Okay. So this is one of a kind that you are going to find, because most of the times they give a set of real numbers. So if you find this one, then people will fail. Like for this kind of question, people will fail. Let's answer A intersection C complement. We want what is in A but D outside C. Now I'll first write the set A. We know that the set A is 0, 1, 2, like that up to 12. Intersection C complement. So let's list the elements outside C. So we know that the elements outside C, we are going to have from 1, right, going in this direction. And then, so what elements can we list? So I'll just put dots like this to mean that there are a lot of elements here. We are going to have elements like -2, -1. Okay, those are outside C. We also have 2 is not in C. We have got 4 is not in C. We have got 5. We have got 7. We have got 8. We have got 10. We have got 11. Those are not in C. And then we have got elements beyond 12 like 13, 14, and all those. I'll put a dots because they continue to go. Now we want what is common, which you are able to see in both sets. That's the intersection. So you can see you have got 1 is not in both, but 2 is in both. You have got 4 in both. You have got 5 in both. You have got 7 in both. You have got 8 in both. You have got 10 in both. 11 in both. Only up to 11. So 12 should not be included. If you include 12, then you have gotten it wrong. So this is the answer to this question. Are we good? Are we good?
Yes, I'm getting it.
Or people are somewhere. We are used with a set of real numbers, so integers are starting to become. So let's work out now b minus a intersect c. So this I can also write it as b intersect a intersect c, a complement comes here. So the first thing that I'm going to work out is a intersect c. Okay, I'll work out a intersect c. Now what will be the element? We know that a is starting from 0 all the way up to 12. So intersect c. So what is common in both? We have got 1, in both we have got 3, in both we have got 6, in both we have got 9, in both we have got 12. So this is a intersect c. But remember we want a intersect c complement. So what will be that set? We are going to have elements before 1 like negative 1, 0, and even others like negative 2, negative 3, negative 5, all those are outside. And then we are going to have 2. Now I need to put dots here because we have got elements this side. We have got 2, we have got 4 is also not in A intersect C. We have got 5, we have got 7, we have got 8, we have got 10, we have got 11, and then we have got elements outside also above like 13, 14, and going like that. Now we want where this set I've listed here is intersecting or meeting with the set B. What is common between it and the set B? So now I can write the answer for B minus A intersect C. In B you can see 2. Also in this set I've listed you can see a 2. In B you can see 4. Also in the set I've listed you can see a 4. You can see a 5 in B. Also in this set there is a 5. You can see 6 is not part, 8 is not part, or 8 is part. So even 8. So this is going to be the set, and that is 4 marks. That's okay? Is that okay? So where listing is concerned, if you miss out an element, my dear, you are losing yourself. Okay, let's work out part B. Since you people are understanding very much, and no one wants to ask. Martha, Regan, are we clear?
On which one, sir?
What you are from solving?
Yeah, for seeing.
Okay. The sets A, B, and C all intersect, and U is a universal set. Shade the part described by the sets in a Venn diagram. B complement intersect A intersect C complement with a complement. Friends, first thing simplify this. It actually has a mark for simplifying. 1 or 2 marks they'll give you. So this will be B complement intersect. Distribute the complement so that will be A complement. What is it going to become?
Union C.
Union C. You can now shade set A, B, C. Now, friends, I'll start shading this part. A complement union C means what is outside A. So shade everything outside A together with the set C. So everything outside A like that. Okay? Together with the set C, meaning that also shade the set C. So I also shade the set C. I've shaded the entire set C, including that part which is in A. Now, where does that meet with the region outside B? Intersection B complement. So you want where that meets with the region outside B, meaning that I'm not supposed to shade B. So this same shade I've said shaded, but remove B. That's the meaning. So everything in B I'm going to remove, but the same set I have shaded, but not in B. So shading sets is very easy, friends. So if you want, I'll just start with the B complement, meaning that what is outside B, but intersection means but should be in this set. So it should be outside B, but it should be in this set. So what does that mean? It's outside B, so mean that I shouldn't shade B whatsoever the matter. This is an intersection, unless if it was union on the middle between the B complement and the A complement union. So if it was union, I could have shaded also in B, but there's intersection. So what is outside B? But it should be outside A together with C. Should be outside A together with C. It shouldn't be in B. Should be outside A together with C. So this is what is supposed to be shaded, this region. Hope it is clear. So we already shaded it now. Just remove that part which we shaded in B because we only want what is outside B. And if you are not asking, it's bad news because in the quiz you'll not be able to ask. Like you can't ask. Okay, express. Yes, Esther. Esther, you can go on. Okay. Express 2 minus 3 square root of 5 divided by 1 plus 2 square root of 5 in the form a plus b square root of c. Anyone to help? What are we going to do from here?
Yeah, we're supposed to conjugate.
Okay, you rationalize the denominator by multiplying by the conjugate. So 1 over 2 root 1 minus 2 root 5 also done by 1 minus 2 root 5. 2 multiplied by 1 is a 2. 2 multiplied by negative 2 root 5, that's negative 4 root 5. Negative 3 root 5 multiplied by 1, that will be negative 3 root 5. Negative 3 root 5 multiplied by negative 2 root 5. Multiply the negative 3 and the negative 2, that will give you positive 6. Multiply the root 5 and the root 5, that will give you 5. And then in the denominator, when you're multiplying number by its conjugate, get the first number, you square it, minus get the second one, the 2 root 5, you also square it. So this 6 times 5 is a 30. So 30 plus 2, that will give us a 32. Negative 4 minus 3 root 5, that will be negative 7 root 5. In the denominator, 1 squared, 2, let's start with the 2 root 5 squared. 2 squared is a 4. Root 5 squared is just 5, so this will give us 20. 1 minus 20 is negative 19, meaning that this will give us a negative 32 over 19 plus 7 over 19 root 5. That's it. As simple as that. Be very, very, very free to ask if you are not clear. The binary operation star on set of real numbers is defined by a star b being equal to a minus b squared minus 2ab. Show that the operation star is commutative. People were proving to say let a be equal to this. They prove, let's say let a be equal to 2 and then b be equal to 3. They find 2 star 3 and then they find 3 star 2. This is okay. But when they've asked you to show like this, they you lose marks. Like others will not mark you when you use this. You are going to use the same letters unless if they gave you themselves to say using this. A is equal to Katwish stash and B is equal to that. Prove that. That's when you can go by that method. But when it is just direct like this, please don't say let A be equal to this and you start doing that. So A star B is given as A minus B squared minus 2AB. I can as well write this as I'll for you the A minus B squared, I'll distribute the square. Get the A, you square it. Get the 2 multiplied by the A and the negative B, that will be negative 2AB. And then get the negative B, you square, that will be positive B squared. And then you have got negative 2AB. So this will be A squared plus B squared, negative 2AB minus 2AB, that will give you negative 4AB. And then also find B star A. Now you have just swapped the position of A and B. So where there was A, I'm going to put B, so that it becomes B minus A squared minus 2BA. Again, expand. This will be B squared minus 2BA minus A squared, and then minus 2BA. Actually, this is plus A squared, not minus. So this will give us, I'll start with the A squared and then plus a B squared, negative 2BA minus 2BA, that will be negative 4BA. So what are we able to see? A star B is equal to B star A. Therefore, the operation is commutative. If you don't write the last statement, you lose a mark again. Just writing since A star B is equal to B star A, then the operation is commutative, carries a mark. Please, every time they've said show or prove, you need to write at the end the statement if you want to gain 4 marks. For quiz one is very simple. Actually, you are going to see people getting 100%, and it will be my joy for you to be amongst they who are going to be getting those 100%. Do you have a question before I proceed? Esther, is it clear?
Yes, sir.
Okay. Yes, Tina.
So can you kindly repeat on the last part?
On the last part, which one?
The last part, like when you are comparing the two.
You mean doing it again, or the part for A star B is equal to B star A?
The part of this.
Okay. So for B star A, we found at the end, we have found that A squared plus B squared minus 4BA. That's what we have found. And then for the first one, which is A star B, we found A squared plus B squared minus 4AB. So you can see these two are the same. So you say since A star B is equal to B star A, then the operation is commutative. I don't know if that's a part. Tina, is that a part or there's something else? I can't get you. Okay,
Yes, it's the one.
all right. Let's work out the next one, which is saying work out negative 1 star 3 and then star 2. So now for this one, first work out what is in the brackets. Negative 1 star 3 star 2. Now, A has been replaced by negative 1 as the first term. And then B has been replaced by 3 as a second term. So just go and substitute. Where there is A, we are going to put negative 1. Where there is B, we are going to put 3. So that will be negative 1 minus 3 squared minus 2 negative 1 times 3. The answer that you get after you perform this operation up to here, now you are going to say star 2, the answer that you are going to get. Negative 1 minus 3, that's negative 4. Negative 4 squared, positive 16. Negative 2 times negative 1, that's positive 2 times 3 is 6. 16 times plus 2, I mean plus 6, is a 22. So what we have is 22 star 2. Now again, A has now been replaced by 22, and then B has been replaced by 2. So this will become, where there is A, put 22 minus 2 squared, then minus 2 where there is A, put 22, and then times 2. 22 minus 2 is 20. Someone wrote 24. 20 squared is 400. 2 times 22 times 2 is 88. So now subtracting, you are going to get 1, you are going to get 2, 1, 3. So the answer is 312. Are we good for this question? Someone has come out. No, I didn't mention. Is that clear? Okay. As far as you can see, you'll still find it, don't worry. So we'll end on just this question. We are ending on here. Express z which is equal to 4 plus 2i over 1 minus 2i squared in the form a plus bi. Now first work out the denominator, which is the 1 minus 2i squared. This is going to give you, get the 1, you square it, that will be 1. And then 2 times 1 times negative 2i, that will be negative 4i. Then get the negative 2i squared, that will give you positive 4i squared. But you know I squared is negative 1, so that will be negative 4. So it says 1 minus 4 is negative 3 minus 4i. So meaning that z is equal to 4. Sorry that you can't see very fast. 4 plus 2i divided by negative 3 minus 4i. So from here, rationalize. So multiply on top and down by the conjugate. That will be negative 3 plus 4i divided by negative 3 plus 4i. When you are multiplying by the conjugate, you just change the sign of the imaginary part. You saw that both were negative, but I've just changed the sign for the negative 4 because it's a 1 with the I. So 4 by negative 3 is negative 12. 4 by 4i, that would be positive 16i. 2i by negative 3i, that is negative 6i. And then 2i by 4i, that is going to be positive 8i squared. In the denominator, multiplying a complex number by its conjugate, get a first number, you square it. That's negative 3 squared. You always put a plus for complex numbers. For such, you put a minus. Get the number in front of I, you square it. That's a negative 4, you square it. Put it in brackets. So this 8i squared is negative 8. So negative 12 minus 8, that is going to be negative 20. And then you have got 16i minus 6i, that is going to be positive 10i. In the denominator, I've got 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. So this is going to be 20 over 25, actually it's negative 20 over 25 plus 10i over 25. Reduce it. This will give you negative 5 can go into 20 and into 25. Negative 4 over 5 plus 2 over 5i. So just that. That's the answer. Very simple. So you guys, like, you need to hammer this quiz. Those questions which you don't know, don't go in the quiz you know that I can't answer this question. Make sure that you know how to answer it before you go there. Okay, let's answer the last question that we are going to do today. So express 0.25 in the form a over b where a and b are integers. So the first thing, let x be equal to what you've been given, 0.253. The 5 and 3 is repeating. This will be equation 1. Make sure that the decimal is in front of the numbers repeating, that is the 5 and the 3. So multiply equation 1 by a 10. Equation 1 by 10. So that the decimal point goes in front. So x times 10, that will be 10x. And that will be equal to 2.53. The 5 3 is repeating. This is equation 2. Equation 2, multiply it by 100 so that the decimal point goes behind the number repeating. So 100 times 10, that will be 1000x. And that will be equal to 253.53. So be equation 3. So the two equations where we've got 1, the decimal is behind the repeat number, and 1, the decimal is in front of the repeat number. Subtract them. So 1000 minus 10, that is 990x. 253.53 minus 2.53, that is 251. So x is going to be 251 over 990. So that is it for this